What's that?
You have to specify what kind of calcium oxalate?
Versus 100 versus 300? Well, I mean, you may see it on the test. It may say, look, this crystal comes in two distinct forms, the dehydrate form and the monohydrate form. Mm-hmm. And you would need to know if that's talking about a calcium oxalate crystal. What kind, if you saw massive amounts of that, what would that indicate?
The poisoning.
What kind of poisoning?
The glycol, whatever.
The antifreeze.
Yeah, however you say it.
And you can say it. You can say antifreeze, or you can say ethylene glycol, or you can say radiator fluid, whatever.
I can't
Okay.
get it out.
But do want you to remember that.
I don't believe.
Cholesterol.
Right. See the little notched edges? And that doesn't mean every single square will have a notched edge, okay? But that's how you identify it. You always normally see some sort of notches cut out in it. Cholesterol. So is cholesterol considered an abnormal crystal?
Yes.
Yes.
But you didn't tell us what disease state. Cholesterol. Is there one?
Cholesterol?
Yeah.
It's just, well, usually it's just something. You've got kidney problems because cholesterol is not supposed to be filtered.
Okay. Okay.
I would never give you that one. Tell me what that is. You can kind of see some nuclear remnants in there. That's a white, that's a red, that's a red. Okay? Don't worry about that. I can't see these guys, so some of them I put on here, I'm gonna tell you they're not good. I think that's a real small calcium oxalate crystal, I think. Did you guys see a little X in there?
Yeah.
Okay. I'm thinking they're wanting you to do that as red blood cells.
It'd be nice if it was like labeled on the slide. They have a logo at the bottom, but they couldn't label what the answer was.
Well, they don't label them because this is sent to labs and you're graded on this.
Well, I mean,
they're not gonna have the answer written on the back.
I get that, but for
I don't have
purposes
their answers
here,
on every one of them. But the ones I give you on the practical will be straightforward. It'll be like, you should know that.
Yes, sir.
I threw a bunch of extra ones in here and I'm not even sure that they're all like really, really good ones.
Let's start.
What I would do if I'm giving you a practical on this slide right here, I'm gonna say, this is without polarization, this is with polarization, and I would say the pH is 5. Now what would you tell me it is? Uric acid. Uric acid. Uric acid looks like this. What's that?
Well, I saw that with the question mark.
yeah, it's not going to pick up the actual pictures, but it's more so for what he's saying.
Remember, calcium oxalate, guys, it can actually be seen in acidic or neutral urine. It's one of the ones that can kind of cross over a little bit.
Antifreeze.
The monohydrate form is found in ethylene glycol poisoning. And I want you to see different pictures of it, because again, urine has different colors to it, and so it's just never going to be one way. Sometimes it's going to have an orange background, sometimes red background, sometimes yellow. Now I know what's written on the back of this one. This is not a white blood cell. This is a trichomonas, okay? And if you can see real close, there's like a little flagella there. But again, trichomonas, I can't give you a trichomonas unless I show you a video where it's swimming around. Okay. Did any of you go do that? Did any of you go and like type in YouTube trichomonas?
I was actually saying it. Only because Matt had it pulled up on your, not because I found it. Yeah, not because I found it.
She's like, oh, you want to see this? I was like, what is it? She's like, look at it. I was like, what is that? She's like, I was like, oh, okay.
There's that. That's the one that I would ask you right there.
Monohydrate, calcium oxalate, antifreeze. Cellular cast.
Yeah.
Yeah, that is a cellular cast. I see the membrane going all the way around it for the most part. I see white blood cells in there.
That's a big head.
Yeah. So if I just said, if I maybe gave this as a bonus and I said diagnose this patient, what would you tell me?
Blood cells in the cast.
Who has white blood cell cast? We talked about it today. Pyelonephritis, upper urinary tract infection, you'll see white blood cell cast, right? That's how you can differentiate cystitis from pyelonephritis.
Yes.
Yeah, those are supposed to be considered. These are gonna be your, actually, you've got an eccentric nucleus, so these might be considered renal tubular epithelial cells. Transitional, they should be kind of in the middle, and your renal tubulars are usually gonna be eccentric, they're gonna be shifted. Yeah, you don't wanna see renal tubular cells. So while we're talking about that, and I should have went over this in, on the review today, what if you have, somebody tell me what an oval fat body is?
That's not what it is.
But what makes it different? Why is it called an oval fat body and not a renal tubular epithelial cell?
Because it has lipids and stuff to it.
Because it's got lipid content sticking on it, right? And those lipid contents, that's what, if you put it under polarized light, you'll see the little Maltese cross. So if I show you a KodaChrome of something and I say, look, this is it without polarization, this is it with polarization, and you see that Maltese cross, I don't want you to call that a renal tubular epithelial cell. I want you to call it an oval fat body, okay? You don't want to see those either, okay?
Hey, if you give me one of the cups, I'll take one home and give Christopher, and you know, he's a kidney failure. He has to have transplants, so. See if there's anything in it.
Yeah, that's a squamous epithelial. I know it looks like there's two nuclei in there, nucleuses in it, but that's what a squamous epithelial cell is gonna look like. What did we talk about in the review today that you need to remember?
Oh, focus on it.
Focus on it.
Because it's big, it's only like bigger.
Highland.
Yeah, Highland cast.
Highland cast, and what could we get that confused with?
Mucus.
Mucus, right? If we were just seeing those lines. Are Highland cast abnormal? Can actually see, okay. What power do we count a cast on? Low power, right? So let's talk about that for a minute. If we're in your analysis, what is high power on the microscope?
40.
And what's low?
10.
Okay, so if I say you're looking at something under high power, what's the total magnification?
400.
400.
Oh no, put it again.
How
You
many
said
of those
high
do
power?
we have?
Okay, I got it now. That's true.
Start looking
I'm
at it
about to
now.
get-
Put the same one on there. Okay.
That's all she's crossed, that's all.
No, it's not early fat body. Because, and I would tell you guys this, if I presented this, for whatever reason it's off, this is it without polarization, okay, that does not look like a renal tubular epithelial cell. See the little dimple in the middle, I call it?
Yeah.
Starch will also polarize light, okay? This is actually a starch grain, all right? That's trash. That's something that's kind of insignificant. But a starch granule can appear in the polarized light as also having the Maltese cross appearance. But I wouldn't do that to you on the practical. I'll be straightforward. I'm not gonna say, oh, no, you're on your starch. I'll make sure that it's very simplistic.
Transitional epithelium?
Transitional. See how the nucleus is right dead in the middle?
Centric.
Eccentric is.
Not eccentric, centric.
Yeah, okay. Eccentric. Is that what that means?
Yeah. That is me.
Cysteine.
Six-sided cysteine.
That one looks like a snowman.
You know, another significant thing in this picture is how many red blood cells there is in that, right?
Yeah.
So we're talking about, hemoglobin earlier? No. Hematuria? Hematuria. Okay.
granular.
Right. And when I worked, we actually, for whatever reason, we had to distinguish one called finely granular from coarse granular. That is a granular cast. We'll see those from time to time. Here's that slide I don't like, but I'll show it to you because I'm seeing it in a lot of different pictures.
Oh, the mucus.
A mucus strand.
Yeah. It's a concentrated mucus.
What's that?
And it seemed a little bit more concentrated than your average mucus.
Yeah. I know you guys know this one, but I want to show this. The more pictures you look at, the better. And cholesterol will polarize light. That's all you're looking at. All I would ask you about this, and I would probably just say, if I was to give you this on the practical, I would say, is this significant or is it trash?
I think it's trash.
I think it's trash.
I think it's
Pete. It's pop.
Yeast.
Yes, yeast. There's also some white blood cells in there, but remember, on yeast, it's going to bud. There's going to be budding. You will see budding yeast a lot more than you will branching hyphae, okay? Branching hyphae is like a severe yeast infection to where you'll see the little, I call them tree branches. So if you're a brand new tech and you're worried that you're doing something wrong, what is something you could do to differentiate yeast from red blood cells?
Oh, hemolyze the red blood cells. You add the acid or whatever it is to
Very
it.
good. You add a real dilute acid, like maybe a 3% acetic acid solution or something, real dilute. The red blood cells will lyse. Okay, and acid will lyse the red blood cells and the yeast will stay there. So if you're trying to figure out what it is, if you add the acid and everything goes away, well, it was red blood cells, right?
Not all yeast produces hyphae, so if it's not budding, it's really hard to tell from red blood cells.
I got another question for you guys. This is just a common sense question. It's not going to help you for your test. What would you do if you spun down a urine? Because this does happen. You spin down a urine, like you get a urine sample in the lab and it looks like blood. I mean, it really does. It looks exactly like blood. You're like, oh my gosh. You know, I mean, it's even thick like blood. Well, of course, you dip it and everything comes up positive, but you spin it down in a centrifuge and you got sediment that's that thick of red blood cells, okay? And so you try to get a drop out of there to put on a microscope slide and you look at it underneath the scope and all you see is just a big blob of red blood cells. What would you do?
You look at the big blob of the red cells first and see exactly if that's what you're looking at. Then you'd add the acid to burst them so then you see everything else.
Okay, I like where you're going with that, but that's wrong.
Maybe
But I do
pull.
like how your thought process was.
Could you pull some out and like dilute it in another solution and then spin it down again?
Dilute it. Now, one thing that you'll see a lot of techs do is they'll like put one drop of the straight sediment like you normally do, and then maybe put a drop of saline, okay, and then get a little stick and mix it up. Even though you're diluting it, there may be something in there that's significant that you can't see because there's so much blood in it, like a cholesterol crystal or tyrosine crystals. There just may be something in it that you need to know. Maybe there's trichomonas in it, but you'll never see it because it's so thick. That's the only occasion that I ever remember actually diluting sediment out, is so you could see through it. Sometimes in amorphous you have to do that. Even though, you know, you let it come to room temperature and you're trying to make all that amorphous go away, sometimes it obscures everything that's in there, so you have to dilute it.
Question. Earlier you said separating the yeast from the blood, pouring some acid on there to get the blood to lyse. What if you poured water?
Well, water is going to definitely lyse the red blood cells, but I think water is gonna play havoc on the yeast too.
It will too, and it may start lysing white blood cells that you're looking for. It's a little bit too aggressive.
All right, this is a pretty good slide here. We're gonna think about this.
Pictures of all the additives and stuff.
The water? No, it's just so hypotonic that it's gonna try to break.
It's a fat body, but it also has
This is actually,
things in it.
this is not a renal tubular epithelial cell. This is a fatty cast. This is a cast that has a lot of lipid content that's sticking to it. So naturally, if you put it in the polarizer, you've got the cast there, and look at all the little Maltese crosses. Okay, so this would be a fatty cast, and then that's it under polarization.
You will have a long career before you see one of those, bro.
Yeah, I've never seen one not like that. How do you guys feel with all this stuff? Y'all feel okay on it? Red cells, white cells, all that? Okay. Let's take about a, tell you what, let's meet in the lab in 15 minutes. Let's take